Hello everyone, welcome to the lecture series on foundation engineering. In this video, we are going to see about different types of shear failure. To make you understand this concept easily, I'll start with an example. Assume that there is a ground surface, it's a wet surface. So I'm trying to draw two different kinds of mass here. One which is just 10 kilogram, another one which is very heavy. It is 1000 kilogram. Do you think that the impression created on the ground will be the same if I drop this mass? Obviously, no. Because of this 1000 kilogram mass, and that to the soil is wet, right? So the depression will be higher. And you can see certain bulging of soil also here when compared to the one that you have got in the 10 kilogram mass. Yes or no? This is what something we are going to study in a technical manner. Basic in 1963 observed that there are three different kinds of bearing capacity failures when a footing failed due to insufficient bearing capacity. They are general shear failure, local shear failure, and punching shear failure. So each of this failure will have different characteristics which have occurred due to different criteria, which we are going to see one by one now. In soil mechanics, we all might have learned that every soil will have its shear strength. So, if the shear strength of the soil is at the verge of attainment, there is a state called state of plastic equilibrium will be created, which means every point on the soil is at the verge of failure. So, in general shear failure, the state of plastic equilibrium will be initially created at the edges of the footing, then it extends downwards and in the outward direction. So it has a well-defined failure surface, the one which is here. And the failure has reached up to the ground surface, and also you can see certain bulging on the ground surface. So the failure will also be accompanied by tilting of the footing, and this failure is sudden. If you plot the load versus settlement for this criteria, you can see the ultimate bearing capacity is well defined for this criteria. So this is your QU value, and this is the settlement. So the full development of the state of plastic equilibrium can be seen in this general shear failure. So it started initially at around the edges of the bottom of the footing, and it proceeded downwards and outwards and reaches up to the ground surface. And this is very much common in low compressible stiff clay and in dense and very dense sand. The next type of shear failure is local shear failure. In local shear failure, the state of plastic equilibrium is not fully developed, which means the failure pattern is clearly defined only immediately below the base of the footing. See here, only up to this point you will have continuous line. The failure surface will not be continuous beyond this point. So that is why we are having dotted lines here. And also the failure surface did not reach the ground surface. So what will be the case of bulging? You won't see prominent bulging as you have seen in general shear failure. The bulging will be only little in case of local shear failure. And this failure is not sudden as you have seen in general shear failure, and there won't be any tilting of the footing. So how would you identify this failure? You will have failure with large settlements. If you happen to plot the load versus settlement plot, you will have a plot like this. From this figure, you can see that there is no prominent ultimate bearing capacity. If you compare this figure with the load settlement plot of a general shear failure, this is load and this is your settlement. You'll have a plot like this. You can see that you can clearly identify your ultimate bearing capacity in this case. But here in local shear failure, you cannot identify the ultimate bearing capacity distinctly like you have done for general shear failure case. So where you can get this kind of local shear failure, in case if you are having a clay of high compressibility, or if you are having a sand with relative density between 35 to 70%, then you may observe local shear failure. The last one is punching shear failure. So here there is no failure pattern is observed. In fact, the failure envelope is not at all developed. The failure surface will be vertical or slightly tilted following the perimeter of the base. So there won't be any bulging of the soil. In fact, the settlement will be very high in the case of punching shear failure, and there won't be any tilting of the footing because the footing itself will penetrate into the ground with a large settlement, right? So there won't be any visible tilting of the footing. The ultimate bearing capacity is not well defined in this case also. You can see the load versus settlement plot. You cannot find a distinct ultimate bearing capacity in this case. So where you can have this punching shear failure if the soil is having a relatively higher compressibility, which means more compressibility than the case of the one you have observed in local shear failure. It is if it is having a relatively higher compressibility, and if the soil is sand having a relative density less than 35%, then you may observe punching shear failure. Here you can see the failure envelopes and the load settlement pattern of general shear failure, punching shear failure, and local shear failure are compared. You can see in general shear failure, the failure envelope is very well developed and reached the ground surface, and there is bulging. Where in the load settlement curve for general shear failure, the ultimate bearing capacity is very well defined. Whereas if you see the local shear failure, the failure envelope is extending continuously only up to the bottom of the footing, beyond which the failure envelope is not continuous. It hasn't reached the ground surface. The bulging is also very mild. If you happen to see the load settlement curve, you cannot find a prominent ultimate bearing capacity. Now, when you come to this punching shear failure, the failure envelope is in fact not at all developed in a proper way. You will see a large settlement. Here also you cannot find the ultimate bearing capacity easily. In the next class, let us discuss in detail about Tersaghi bearing capacity theory. Thank you.